Hello everyone. In today's presentation, we will discuss the second part of computer-aided quality control. So, in first part, we have discussed majorly the introduction part of computer-aided quality control and contact inspection methods. Now we will discuss the non-contact inspection methods. So basically, these are divided into two categories. First is in optical, second is non-optical inspection methods. So in optical there are two methods: machine vision system and scanning laser beam devices and photogrammetry. Or in non-optical there are three methods: electric field techniques and radiation techniques and ultrasonic. These are three techniques which comes under non-optical inspection methods. So in this method, we use particularly some forms of energy than light to perform the inspection. So in non-optical, we use the other form of energy, or we can say other forms of energy than light. So we don't use the light source, but we use some kind of energy like electrical field, radiation, and ultrasonic in non-optical inspection method. But in optical, we use particularly light as a source. So if we have, for example, this kind of complicated workpiece and we want to inspect the geometrical features of this product, then we will use the non-contact inspection probe for this particular robotic arm. So these are the machine setups of your contact and non-contact inspection. In contact, we are using like contacting probe as a which will touch the surfaces of the work part, and it will we can see or we can inspect the component of whatever we required. Again, this is the non-contact inspection where we are using some kind of laser or x-ray rays, where without touching the workpieces we can inspect, or we can see the geometrical aspects of the components. So this is where we can do during manufacturing time, or we can inspect during the machining time of the production time of the components. Whereas in this method we need to take out the component and we will take it to the inspection area, then we do inspection process. So we need to understand the advantages of non-contact inspection method. So it usually eliminate the need to reposition the part, so that we have already been discussed. Again, non-contact inspection is usually much faster than contact inspection, and it eliminates mechanical wear encountered with the contacting inspection probe because it eliminates the probe. Fourth advantage is it reduces potential danger to people who must touch a hazardous material if contact inspection is used. Fifth advantage is it removes the possibility of damage to the surface of a part, which results in high, or we can say uh, whatever surfaces we are going to inspect. So it removes the possibility of damaging that surface, which results high during the contact inspection. So during the contact, there may be possibility of damaging that surfaces of the whatever we are inspecting. So the in non-contact inspection of the first method is machine vision. So that in that machine vision system include the microprocessor based television and computer vision. There are majorly two components. So the typical machine vision system consists of a TV camera, a digital computer, and an interface between these both two things. So as a function as a preprocessor, so the combination of system hardware and the software data is the picture and analyze the image by comparing it with the data stored in the memory. So whatever the data is stored in memory, or we can say standard geometrical aspect, so whatever it take out the pictures, then these pictures are analyzed with the stored one. So the limitation of the machine vision system is the problem of dividing the picture into picture elements. So So that is main problem. So whatever it take the picture, then it will split in different elements, then it will compare it. So see, this is very similar to the problem encountered in the development of graphic terminals of the computer aided design. So as we do in computer aided design, so first we split in different terminals or graphic terminal, then we combine different graphic images, then we make one. So one may be that the object in front of the camera must be capable of being divided into area of contrast, light and darkness. That is major requirement while capturing with machine vision system. So there may be it may be capable that it could divide into different areas in contrasting like lightness and darkness. So it is on capability of machine system that it recognize the object in the viewing area. So whatever the component or the part will comes in its viewing area on that particular area, that only will be recognized by the machine vision system. So there are majorly two problems with the non-contact, or we can say machine vision inspection system. One is non-contact gauging of dimensions. So whatever we are not able to detect the component, or we can say the part of that component, that then we that part that dimensions could not be fetched. Then inspection based on pattern recognition of the object features. So particularly we inspect on the basis of pattern recognition. Next method is scanning laser beam devices. So it relies on the measurement of time rather than light, although a light sensor is required in this operation. So here we focus majorly on measurement of time parameter. So in the next slide we will see the schematic diagram of this particular method. So if its operation is pictured in figure, a laser is used. So in this particular mainly laser source is used to project a continuous thin beam of light. So a rotating mirror, again a mirror used to deflect the beam so that it swept across the object to be measured, and the light sensor is located at the focal point of the lens system to detect the interruption of the light beam as it blocked by a object. So the time lapse corresponding to interruption of light beam is measured to determine the desired dimension of the part. So typically a microprocessor is programmed to make the conversion of the time lapse into dimensional value and to perform other functions such as signaling an automatic part rejection mechanism to eject a defective part from the line. So this is the main working after detecting the defective items. So in this figure we can see there is one laser source which will emit the laser. Then rotating mirror used to deflect the laser beam source. Then using the lens it will focus to the object. So whatever object will comes into the path, that then it will give the images of that on optical detector, and it will convert into the processing signal. So that is our second method. Next method of non-contact inspection is photogrammetry. So this method involves the extraction of three-dimensional data from a pair of photographs taken at different angles. So what we do, first we take the some photographs at different angles, then we prepare a 3D data using these photographs. So the two photographs can be combined once in a way that stereoscopic, using a pair of photographs to form a three-dimensional image for the viewer. So in the measurement process used for inspection, the two photographs are read by a device called monocomparator. Then these two photographs are read by a device, this we call monocomparator, or to establish coordinate and position of the object. So these data are then computer analyzed to extricate the desired information. So the drawback of the conventional photography technique is that the need of photographs and an inconvenient and time consuming step in the procedure. So wherever this is the main drawback, first we need the photographs so that we can get on, we can analyze, but it's a time consuming procedure. So an improvement in the technique which is being introduced will delete the photographic step. So instead of the image from two cameras setup in a stereoscopic configuration, will send visual data directly to a computer for mathematical analysis, and real-time extraction of the dimensional data can be done. So this arrangement is illustrated in this figure. So this is the object and this is the two two camera is situated at different angles. So it takes the we can say pictures at different angles. It will set to image processing computer, and it will directly analyze the photographs, and it will create the geometrical dimensions of that object. Next, non-inspection method is radiation technique. So in this radiation technique, we use X-ray radiation technique for purpose of non-contact inspection in metals and non-metal industries. So the amount of radiation absorbed by a material can be used to measure its thickness and other quality characteristics. So in a typical application is a rolling mill industry. An X-ray scanning unit measures the thickness of the plate or strip going through the roll so that the proper adjustment can be done in the rollers. So the X-ray techniques are also used to inspect weld quality in fabricated steel and aluminum pressure vessel and pipes. In this case, the radiation can be used to detect flaw and void in the weld. So usually, like we have large pressure vessels. So in that, we can use this technique to see if there is any defect or any kind of welding defect left during the fabrication process. Then this technique could be used for inspection. Next technique is ultrasonic. In this method, we use the ultrasonic, we can say high frequency. So it involves the use of very high frequency, about 20,000 hertz sound waves to indicate the quality. So the principal application is in non-destructive testing of materials, that is done using this particular sound waves. So this technique also be applied to the problem of determining dimensional features of work part. So one approach called acoustic phase monitoring, so that involves the analysis of sound waves reflected from the surface of an object. So the sound waves are produced by an emitter and directed against the object. Assuming that all else remains constant, the reflected sound pattern from the object should always be the same. So during the inspection, the sound pattern from the work part is analyzed by a computer program and compared to the pattern of the standard part, one that is known to the accepted quality. If the pattern of the test part differs significantly from the standard, then it is rejected. Next method is electrical field technique. So there are various types of electrical field techniques that can be used in non-contact inspection method. So majorly we use three types of electrical field. One is reluctance. So the reluctance transducer are proximity devices that indicate the presence and distance from the probe of a ferromagnetic substance. So we use that kind of sensors, though the limitations of that device is that the object being inspected must be electromagnetic. That is main limitation, because the material other than the electromagnetic material we can't inspect using this particular transducer. Second is capacitance. So the capacitance based transducer can be used for measuring the distance of a object from the face of a probe. So the measurement is based on the variable capacitance from the part of probe coupling. This capacitance is inversely proportional to distance between the probe face and the part. Thus the distance can be calculated. So the capacitance transducer can be used to detect a variety of materials. The material must be an electrical conductivity, conductor. So the materials which are electrically conductive, that can be only inspected using this capacitance based transducer. Other materials cannot be inspected. Next technique or next device is inductance based transducer. So that inductance system operated by subjecting the object to an alternate magnetic field by means of electromagnetic coil that result in small circulating current, eddy current, or generated in object. These eddy current in turn create their own magnetic field which interact with primary field. So this interaction affect the impedance of the coil, which can be measured and analyzed to determine the certain characteristic about the object. So these are the methods which are being connected with electrical field techniques. Thank you very much.